Hi everyone, welcome back to our course in college algebra. Dr. Tom McNamara here. We're continuing our work with exponential and logarithmic functions. In this video we're going to talk about solving exponential and logarithmic equations. Now the big idea with these types of equations is whatever kind of equation you have, you want to convert it to the other kind. So you might want to go back and look at the first video we did on logs to refresh your memory on how to convert between an exponential equation and the equivalent logarithmic equation. Because if you have an exponential equation, and of course by exponential equation I mean an equation with an unknown exponent. So if you have an equation with an unknown exponent, the strategy is first, isolate the term with the unknown exponent, and then second, convert to the equivalent logarithmic version of that equation. On the other side of the coin, if you have a logarithmic equation where the unknown is inside a log expression, get all the logs combined on one side and then convert to the equivalent exponential equation. And this is what I was meaning by saying, whatever kind of equation you have, you need to convert it to the other kind in order to solve it. So if you have an exponential equation, you need to convert it to a log equation. If you have a log equation, you need to convert it to an exponential equation. And just for a quick review, 2 cubed equals 8. That is an exponential equation. It's an equation that involves an exponent. The equivalent log equation is log base 2 of 8 equals 3. Okay, so remember, the base of the log always matches the base of the companion exponential function, and the log tells you the exponent. So you want to hit this target as a power of 2. You want to take a power of 2 and get 8, use power 3. So that's what this is saying as well. All right? So we'll need to use that when we are solving exponential and logarithmic equations. Okay, let's do a quick example of a problem that would lead to solving an equation with an unknown exponent. So let's say we deposit $500 into an account that pays, let's call it 3% interest, compounded continuously. Okay, so we deposit $500 into an account that pays 3% interest compounded continuously. How long before we have $1,000? Okay, so we see this keyword here, continuously compounded interest. So right away, we're thinking about this model here. A equals PE to the RT. What you want to do is fill in all the values that we know. Okay, so we know P, we know the principal is $500. So I'll put a 500 right there. E is a special number, okay, that never gets filled in with anything. It's like pi r squared. You never fill in a value for pi. Pi has its own special value, just like E does. All right, so 0.03, because it's 3% interest. I know the amount I want to end up with. It's $1,000. The only thing I don't know a value for is t, time, because it says how long before we get $1,000. So I want to know the value of t that I can plug into this equation to make the right-hand side equal 1,000. Okay, so this is an equation with an unknown exponent. So what I would do is start by isolating e to the 0.03t. Remember our strategy. Isolate the quantity with the unknown exponent. Get that by itself on one side. All right, so if I want e to the 0.03t by itself, I have to get rid of this 500. The 500 is multiplied by e to the 0.03t, so I should divide both sides by 500. If I divide by 500 over there, I get a 2. Okay, so this is my first step in the strategy. Isolate the quantity with the unknown exponent. The second step is convert to the equivalent log equation. So log base e of 2 equals 0.03t. Remember, logs tell you the exponent that you need to use to get a target. Okay, so I want this exponential to give me a 2. What exponent do I need to use? Well, it tells me, the log function tells me the exponent to use. Fortunately, we're dealing with log base e. You have a log base e button on your calculator called ln. All right, so I'll use that notation here. Notice what I did here. I want to solve for t. Okay, fill in all known values, and then what we're going to do, once all known values are filled in, we're going to solve for t. Solve for the remaining unknown value. So in order to get t by itself, I had to divide both sides by 0.03. Okay, so let me grab a calculator real quick, and we will approximate the value of t that makes this happen. So on my calculator, I hit ln of 2, and once I've got that, I divide by 0.03. Okay, so this is approximately 23 years. Okay, so if you're just going to let the money sit there in your bank account, and you start with 500, it'll take approximately 23 years to double your money. Interesting thing about compound interest like this, the 23 years to double your money applies not just to $500, but to any amount. If I just put in $5, and I was interested in how long it takes to double that, I would start with a 5 here, double that on the other side, a 10, I would end up with this equation. If I started with $1 million, 1 million over here, 2 million over there, you divide, you end up with this equation. So it would take 23 years to turn $1 million into $2 million. Just like it takes 23 years to turn $500 into $1,000. This is called the doubling time for an account like that. Okay, let's do a few additional examples of solving exponential equations. Solving equations with unknown exponents. Alrighty, so solve each. Okay, so let's do this one. 2 times 1.05 power x plus, where is it? I lost my place. Plus 3 equals 10. All right, so we have an equation here with an unknown exponent. So we follow our strategy. isolate this quantity. So I eventually want to have 1.05 to the x equals something over here. I want that by itself. How could I get that by itself? Well, firstly I should subtract 3 from both sides, because I got a plus 3 over here. I want to get rid of that. Got to do minus 3 to both sides. So that gives me a 7 over here. Now I got a multiplier of 2 over there. I want to get rid of that multiplier of 2, so I divide by 2, so I get this. Okay, so first step is complete. Isolate the quantity with the unknown exponent. Now, once you've done that, convert to the equivalent logarithmic equation. Log base 1.05 of 7 over 2 equals x. Okay, remember, the base of the exponential is always the same as the base of the log. The thing on the other side of the log is going to be what the exponent was in the exponential equation. So converting to a log puts the unknown exponent by itself on one side in this case. All right, so I can evaluate this. I don't have a log base 105 button on my calculator, but we do have the change of base formula. So I can do log of 7/2 and divide that by log of 1.05. Okay, that's easy enough. So take the log of 7/2 and then divide that by the log of 1.05. Okay, I'm getting approximately 25.68 if I round to 2 decimal places. Okay, approximately 25.68. Let's do another one. Let's do a log equation here. An equation where the unknown is inside a log. Okay, so 5 times ln x equals 10. 5 times ln x equals 10. All right. So first thing I want to do is get the log isolated on one side. So how do I get rid of that 5? Well, I would divide both sides by 5. Now I would convert to the equivalent exponential equation. Just one thing I'm going to do before I convert. I'm going to be really explicit. You probably don't need to write this step down, but just so I have everything in the right place, I am reminding myself that ln means log base e. Okay, so that's going to help me with my conversion. E to this power over here equals x. Okay? Remember, the log tells you the power that you should use on this base. The base of the log always matches the base of the exponential. So if we're doing log base e, we're talking about raising e to some power. What power? The log tells you the power. That's the power. Raise e to power 2, and that'll hit this target. That'll hit x. We can stop right here. If you want, you can approximate e to the second on your calculator. Okay, you can do second and then hit the ln button, and that'll give you e to the x. So that's my calculator's approximation for e squared. But this is good enough. This is the exact answer. My calculator is only giving an approximate answer. Okay. One more. Okay, let's try log base 6 of 2x plus 4 equals 2. Okay, in this case, the log is already isolated. It's log of something equals stuff over here that has no logs. Okay, so I'm going to convert right away. 6 power 2 equals 2x plus 4. Remember, base of the log always matches the base of the exponential function. The log tells you the power to use. So you're taking 6 to this power, 6 power 2, and you get whatever's in there. Okay, now it's just a matter of solving for x. We know 6 power 2 is 36. Subtract the 4, you've got 32. Divide by 2, you get 16. Okay, x equals 16. Okay, so by converting, we solved our equation with an unknown inside a log. So the key idea with these exponential and log equations is whatever kind of equation you have, you got to convert it to the other kind in order to solve it. So make sure that you spend some time reviewing how to convert between an exponential equation and a logarithmic equation.